All right, Grizzly Rizzly is in the house, ready to teach you guys 8.7 factoring special products. All right, so as a warm-up, I would pause the video, and can you guys try 1 and 2? So I'm going to do these very quickly. So we're going to find the product. So m times m is m squared. M times negative 3 is negative 3m. And then we're doing our double rainbow. 3 times m is positive 3m, and 3 times negative 3 is negative 9. And then add like terms in the middle, but what you're going to notice today is that they cancel. I think we've seen that before. And the answer is m squared minus 9. Okay, number 2. 2y times 2y is 4y squared. And 2y times negative 3 is negative 6y. And then we're going to do the same thing with the 3. 3 times 2y is positive 6y, and 3 times negative 3 is negative 9. Oh my gosh, look at this, guys. The middle terms are opposite, so they cancel again. So final answer is 4y squared minus 9. Okay, so that's why this lesson is called Special Products. Today we're going to do the ones where the middles cancel. And I want you guys to look at a pattern here. What do you notice? What do you notice between these two? They are exactly the same, but one's plus and one's minus. But they both have an m, they both have a 3, so they're exactly the same, but just opposite sign. Okay, when that happens, the middles cancel. Same thing over here. 2y and 2y, 3 and 3, but one's plus and one's minus, so the middles cancel, and that's why you're left with 2 terms. Okay, so here we go. If your expression only has 2 terms, then that means that the middle terms must have canceled each other out. All right, so here is the pattern. And actually, we're gonna redo this one. Instead, let's keep it real basic. Let's do x squared minus 100, let's say. Okay, so your job is to factor that. So just like before, let's draw our 2 parentheses. And let's see what we got. So we need 2 numbers or terms that multiply to x squared. So what do you guys think has to go here and here? If you want to get 1x squared, you need a 1x and a 1x, right? Okay, and then we need the last number in each parenthesis. We need these to multiply to negative 100. But, okay, there's a lot of options. The inners and the outers have to cancel, right? Because there's no middle term. So that means they have to be the same number. So what's that number that if you multiply it by itself, you get 100? Well, hopefully you're thinking 10 and 10. And then remember up above we said they have to be identical except one's plus and one's minus. That is today's pattern. It's called the difference of 2 perfect squares. If this is a perfect square and this is a perfect square, then this is your pattern. One's plus and one's minus. All right, let's try some. So, number 1, let's draw our 2 parentheses. Okay, we have y squared minus 16. This is going to fit that pattern. To get y squared, we need y and y. To get 16, what do we need? It's got to be the same number. What times what is 16, but it's got to be the same number. So it can't be 8 and 2. It's got to be the 4 and the 4. And then, in order for the middles to cancel, one's got to be plus and one's got to be minus. It's called the difference of 2 perfect squares. All right, number 2, same thing. Parenthesis, parenthesis. We need 2 numbers that are going to multiply to 25m squared, and they have to be the same. So it's got to be 5m and 5m. I think you guys are getting the hang of this by now. And then we need two numbers that multiply to negative 36. So what times what is negative 36? Well, they have to be 6 and 6. And in order to be negative and to get the middles to cancel, 1 is plus and 1 is minus. Awesome. Okay, let's make it a little bit harder on the back. Sometimes you guys have to pull out a GCF first. For example, number 4. If you notice, 8 and 18 are not perfect squares. So first we have to divide out a GCF. So what's the GCF of 8 and 18? What's the biggest number that divides into 8 and 18? And it's 2. So go ahead and pull out a 2. We're going to divide out a 2. And now we're left with 4 minus 9n squared. And now let's do our trick, because those are perfect squares. Okay, what times what is 4? It's got to be 2 and 2. And then what times what is 9n squared? It's got to be 3n and 3n, and 1's plus and 1's minus. And then when you guys divided out a GCF, just make sure that you bring that number out front, just to show that it's still there. Let's do one more of those, because those can be a little tricky. All right, last one, number 6. So number 6, they're not perfect squares, and let's divide by a GCF. So what can you guys divide out of 6 and 54? What do they both divide by? The biggest thing they both divide by is 6. And if you do that, you're left with 1m squared minus 9. And this we know how to do because those are both perfect squares. All right, draw your parentheses. What times what is m squared? It's got to be m and m. Okay, and then what times what is 9? It's got to be 3 and 3, but in order to make the middle terms cancel, 1's plus and 1's minus. And then whatever that GCF was, make sure you drag it out to the front. That is your final factored answer. All right, awesome. And then feel free to stop. Feel free to stop here. But I'm going to go over a little chart that we're probably going to do in class too. But if anybody wants it now, here you go. Here's just like a recap of the 3 types of factoring. Always check for a GCF first. So always check for a GCF first. And then, if there are 2 terms with the middles missing and they're perfect squares, you're going to use the perfect square trick. So use the perfect square trick. And then lastly, if there are 3 terms, a trinomial, you're going to do that guess and check like we did before. Guess and check method. These are the 3 types of factoring. GCF only, perfect square trick, and then the guess and check trinomial. Okay, so I'm going to run through the answers if anybody's still watching. The GCF here would be 2x, and if you divide it out, remember you divide and subtract, you would get 2x minus 1. Okay, this one is the difference of 2 squares. To get x4, we need an x squared and an x squared. And to get an 81, we need a 9 and a 9. And then 1's plus and 1's minus to get the middles to cancel. And then lastly, the guess and check trick for a trinomial. To get x squared, we need x and x. To get negative 4, we need two numbers that multiply to negative 4, but the inners plus the outers have to add to negative 3. So what are two numbers that multiply to negative 4, but then add to negative 3? And it's got to be negative 4 and positive 1. All right, so that was just a little recap of factoring. All right, thanks guys. See you tomorrow.